So welcome back. Now we'll talk about how can we actually iterate over a matrix. In previous sessions, we've understood how can we iterate over a list. Now we'll understand how can we access over a 2D list or a matrix. Okay, give the heading. Iterating over a matrix. Okay, and I'll talk about various ways here. So we were actually working with a matrix. Let's print it. So this is our matrix. Okay, 3, 5, 7, 4, 2, 6, and 6, 7, 8. Okay, and in visual format, this is how it looks. In visual format, this is how it looks. Okay, now one way is that I can actually treat it as a list of list and I can iterate over it. Okay, for example, I can actually find number of rows as n, which is length of a, and number of columns as m, which is standard n and m, eminem, eminem. Okay, so n is length of a of 0, which is number of columns. Okay, I'll comment this. These are number of rows and these are number of columns. Now what I can do is I can say for I in range n, and using nested loops, I can say for j in range m. Okay, print a of ij, because to access an element, I need two indices, row index and column index. Now, as you can see, it is not actually helping you understand what is happening. What I'll do is I'll say formatted string, okay, and I'll say element present at row equals to I and column equals to j is this. Now let's see. Very interesting. Element present at row 0 and column 0 is 3, because as you know, first element will be 0, 0. Second, it will be still 0, I will be 0, but j will be 1, because this is a nested loop, outer loop, inside loop. So 0, 1 is 5. Can we confirm that? 0, 1 is 5. 0, 2 is 7. So 0, 2 is 7, and so on. Okay, so this is one way to think about it. But second way, which I personally prefer when there is no restriction on mandatory using indexes, is direct access. And I'll tell you one use case of that as well. Okay, so this is way one using indexing. Way one using indexes. Now way two is your direct access, as we have discussed in list. Direct access. Now understand. Suppose I have this list with me, correct? And if I say for row in A, print row, or row in A, print row, what will it do? This will be first row, this will be second row, this will be third row, and this is just element, right? Row is just an element of the list. It is actually printing row 1, row 2, and row 3, correct? Now imagine if I again access over this row. Given this list, how can you access over it? You say for element in this print element, right? I will actually combine this. I will write it like this. For element in that row, whichever row you are currently in, nested loop for element in that row, okay, print element. So what will happen? It will access the elements of every row at a time, row at a time. But what I want to do is I want to help you understand this by printing it as a matrix. Okay, so 3, 5, 7 like this. I want to print it like this. Just make it more good looking, and you can understand that after some practice. Okay, I will say end it with some space, because every row element should be separated by space. And once that row is done, move to the next row. Same as your pattern printing, that's it. Okay, so first row, second row, third row. Now your matrix looks like a matrix, right? Now we are printing it as a matrix for easier understanding. Now, why I particularly like this approach is because let's say in worst case, suppose you are working with 2D lists which are not metrics. For example, where every row is of different size. It's possible, right? So as an example, works for any nested list. For example, if you have A equals to 1, 2, 3, and second list is just 4, 5. Suppose this is the case, 1 to 3 and just 4, 5. This is not a matrix, but this is a nested list, a list within a list. So this approach works for it because here the number of columns are not fixed, but you're not actually relying on the column index. Okay, so you can still say for row in A or element in row, print element, print element, and you can say end is, and once you are done with the row, print 1, 2, 3, 4, 5. Okay, so I know that this can be a bit complicated at first because you have to visualize a lot. I would recommend you take a pen and paper, try to understand it line by line, and practice it as much as possible before you proceed ahead. With that, we have covered a very interesting chunk, very interesting topic of how can we print a matrix. Thank you.